Hello, everybody. I'm Alexy Khrabrov, the organizer of SF Scala and SF Spark, and here we have a guest meetup. We have San Francisco Bay Area Machine Learning, which is our sister meetup, hosted at Nitro tonight. And it's also a joint meetup with SF Text. And here with us we have Moody, who is a data scientist at Stitch Fix.
Thank you very much for having me, Alexy.
It's great to have you, and I must notice that Chris gave a talk last year at Text by the Bay, which is one of the highest rated talks, which talked about lda2vec.
That's right.
And many people remarked that they finally understood lda2vec, and it was really great. So today we have a new algorithm called lda2vec, and looking forward to that. But before that, I want to ask you, Chris, Stitch Fix is a very interesting company. We have multiple talks in Data by the Bay in May. From it, can you describe the problem and how it leads to so many interesting data science questions?
Yeah, absolutely. I mean, absolutely. Like Stitch Fix is an unbelievably interesting problem, and I think when you first scratch the surface, you don't really think it's super interesting, right? So, for example, 2 years ago, I was doing a physics PhD, doing astrophysics and supercomputing. And if you ask me now if I would be doing clothing, especially like women's clothing, I'm like, get out of here, right? But once you start to dive in a little bit on the surface, you start to see all kinds of really interesting patterns. For example, like fashion is like this incredibly interesting conversation that a whole community of people are always having with themselves, and it changes over time, right? So trends are changing in time, and they're extremely like sort of sparse. They're very high dimensional, and they're changing. And one of the ways that you can actually try to understand that, right? So for example, leather might have been in like last year, like tiny little leather straps, but this year it's like patchwork denim, right? Or maybe it's just like, and maybe that's like a full month trend, maybe it's like a full week's trend. And so if you want to capture someone's individual unique style, some of that's going to be made up by this sort of like globally changing component. Some of it's going to be regional, some of it's going to be time, some of it's going to be individual to that client, right? And the way that we try to understand that fashion and those trends is by the same way that people describe that clothing. And so that's why text is such a powerful, useful thing here. Because otherwise it's extremely difficult to find these trends. You have tens of thousands of items. You have like this really sparse time series changing all the time. And that's why it's such an interesting problem. Like, how do you solve that? How do you predict all those trends, right? It's basically a stock market on fashion. And at the same time, you don't get like these little stock tickers out. You get like text out, right? So, and you don't get just text out, you get it for individuals loading onto like those individual things. So anyway, I could go on and on and on.
Oh, interesting. So I've not realized. So basically, so the users describe their preferences in text. How large are these texts? The Twitter size, the paragraph size, how long the description is wrong?
Totally depends. So it depends on like where you're talking about. So right at Stitch Fix, I should actually probably explain, is if you go to the website, you see almost nothing. You go, you register, you tell us a little bit about yourself, what your size is, what your weight, what your height, and like we ask you a few questions about, do you like this shirt or do you like these jeans? No, yes, no. Very minimal registration, and maybe you fill out like a paragraph about yourself that maybe like tells us something like. Like maybe like you're an expecting mother, or maybe you work in medicine in some way, and you'd like clothes that aren't just scrubs, right?
Okay.
And so that's like what we have to start off with, and that's what a stylist then looks at, tries to send you like the right bit of clothes, and you don't get to see these clothes before they show up, and so that's part of the promise, right? Like that we'll try to find clothes perfectly curated for you. The box shows up, you open it, you put on some of these clothes. And you immediately start to like, maybe you hate it, maybe you love the fit, or maybe you love the color, but something else was wrong, or maybe we knocked it out of the park and got it completely right. Either way, you write that reaction down, right? And it's really, really hard to design a survey that just gets every single possible thing that you could have liked. Maybe it's like the polka dots like that were kind of strange and they were in last year, but not in anymore, right? Or maybe this particular kind of fabric like you're allergic to. Right? And so those are very specific, concrete things.
So you have a text box for feedback, which can be free-flowing text.
Sure. But the big challenge here is that how you describe style is, it's an artistic concept, right? It's really hard to build giant sets of attributes over this, but the text gets you that. And so that's why we're so incredibly interested in all of this, because we can actually think we can build a style space We can think that these clothing items are very similar, that these clients are very similar because they describe things in the same way. And it turns out to be a very powerful idea.
So you see that it kind of bears out that people can be clustered, the styles can be identified. So the fashion is then like the collective trend in that space. Interesting. So you probably are like one of the few people who have an idea. You can probably see like computationally defined fashion.
That's right. And I think that's a really, really, really motivating thing, right? Like when you look at like the trends in machine learning, like there's lots of barriers that have fallen in the last few years, right? Like AlphaGo won like a few months ago. Word2vec, when it first came out, you started to really feel like you could understand words. With a lot of like deep learning on images, you start to think that computers can actually understand images. I think that we are very close to understanding fashion, right? And fashion's a very art, but it's also personalized, right? And I think we're just at the edge of trying to describe those things quantitatively.
Interesting. Do you try to define, distinguish fashion by geographical area, by country? Like, do you see kind of it clustered in that space?
I think that's like a really interesting question, right? Like how much of your personal taste is, say, influenced by your friends, right? How much of it is influenced by your occupation? How much of it by your region? How much of it is unique to you, right? Like how much of it is a reaction to who you were a year ago, right? Like for example, I go back and look at my closet and I look at the clothes that I had like 2 years ago and I'm like, I'm not wearing that anymore, right? Perfectly fine clothing, but it's out of fashion now, right? And so you coupling to yourself is also like an interesting sort of like reaction that can happen, right? So now how do you can write that down as an equation. Now how do you find the coefficients there? How do you find the latent features? How do you find what's important? I think that's like what our algorithms team at Stitch Fix is trying to do in a large part. Trying to describe our clients, trying to describe our merchandise, and trying to figure out what the whole styling experience is like.
So I understand you guys are involving a human in the loop.
Oh yeah.
Right. So how can you talk a little bit about that, because it's kind of a combination of humans and machines.
Yeah, that's a huge part of our business, and I think for us anyway, it's an enormous competitive advantage. Not many. I think it's easy to become obsessed with writing the most awesome machine learning, the most awesome deep learning algorithm ever. But I think fundamentally where we're going to be for at least the next like 20 years is seeing new forms of like humans interacting with machines, right? And so that's where our HCOM team, our human computation team, comes in handy, right? So we have several thousands of like fashion experts, our stylists, and that is a computing resource, right? That is a pool of experts that we can ask and answer questions from. Like, what does this style mean to you? Can you add tags to this style? Can you try to interpret this style in a way that our computers can do something with that data? And that is incredibly powerful, right? And so suddenly, even like at a very low level, we get things like, at the very least, we get like labels for our data sets, right? We can certainly start with that. But I think there's also really interesting parts, like what is a machine really good at, and what is a human really good at? For one, the human is extremely good at forming relationships with our clients. Our stylists are extremely good at forming relationships, at understanding our clients, of capturing trends, of capturing all kinds of different contexts, of reading the text, for example, of looking at their Pinterest boards and trying to figure out a cohesive form of their style. What's the computer really good at? Okay, it's really good at rote calculations. So like a lot of things like this particular item is extremely popular. Like we should, probably put that up there. It's probably really good at figuring out the sizes of different things. Lots of things that can be like numerically quantified. Like don't make a stylist do an inner product. Don't make her do a dot product in her head between client features and item features in some way, right? But do give the information that a stylist can then use. So text, I think, is actually a very big example. Text is somewhere where a computer can kind of understand a little bit about what's going on. So like you can kind of do searching, like searching's okay. But understanding the nuance whenever she says that, I want exactly the same thing, or I love this everything about it, but I didn't buy it because it's half a size too small. Now, a computer's just going to see that she didn't return that item. It's going to be a little bit hard to parse out exactly the right kind of action that you should take there. But that's exactly the kind of thing that you can then maybe surface and bubble up to a stylist in a particular way. And then a stylist can then like action off of it. So it's this interaction, I think, between humans and machines that's like super, super interesting. And it's at the heart of what our human computation team is trying to do.
So are you guys trying basically to see where this divide should be? What kind of actions you should propagate to the stylists and see what they're going to do?
Yes.
Interesting.
Absolutely. And that's a really, really interesting boundary. Really interesting, because you're seeing it change like every year. Every year, like new algorithms come out, and there's a new way where you can interact with stylists. Like you can make stylists more efficient. Like they can use tools in new ways. And I think it's largely driven by things like computers can start to understand images. So maybe she doesn't have to look at the whole. Maybe the client or the stylist doesn't have to look at like the whole Pinterest board. There's hundreds and hundreds of pins to try to figure that out. Maybe the stylist doesn't have to look at like every single comment that a client has written. Maybe we can show just the most relevant ones. Still let the stylist read them and get a notion of what's going on, and action off of that. But show them just only little bits that the computer has deemed relevant in some way. And so that combination of human and machines only going to get closer and closer and closer, I think, with time. And now what I think would be really interesting is if other companies started having sort of like human computation teams inside of their own infrastructures.
It looks like it's becoming human in the loop. I think last year we had a few companies. We had Datalingo, we had Stitch Fix, and since then I think I've seen more kind of companies appear, right? I think the term kind of become more widespread, human in the loop. So I think it's really interesting, and you guys obviously kind of have done a lot of work. So it just occurred to me when I describe this, I have an interesting challenge for you guys, right? Or kind of an experiment, right? So as you know, Data by the Web conference was at Galvanize, which is also a co-working space, home for many startups. And obviously a lot of startups are run by young founders. So every time I come there, I kind of sense that there is an image, right? There's a fashion for the startup founder in San Francisco, right? Like there are like certain kind of jeans, and certain kind of shoes, and certain kind of bags, and jackets. And obviously, you have to fit that image, let's say, to pitch to a VC, right? They're signaling in a certain way that you're a startup founder, right? So I'm curious, right? And so do you guys cater to men? Let's say I want to deck out myself as a startup founder. Let's say I can make a lot of pictures, like a few pictures, have a lot of, pictures from my conferences where we have a bunch of kind of, galvanized folks and generally startup founders, right? So let's say, how would I go about, and like I just arrived from foreign country, like the fashion is completely different. I kind of sense, like in order to make it here, I need to dress up as a startup founder, but I cannot really put my finger in it. Like I need basically a personal tailor in the old times, right? But like obviously I don't have one, so I'm going to use Stitch Fix. How would I go about it?
I feel like you've just given my whole pitch for Stitch Fix Men's. We launched Stitch Fix Men's, I think last week.
All right, I didn't know that.
So it's currently in beta. So if you want an invite, and it sounds like you do.
Yeah, absolutely. I was struggling with this problem every time I come to Galvanize.
But I mean, that's not a unique problem, right? Like people need particular clothes for particular occasions. And if you want to be successful, you'll do that, right? Like especially in this case, right? Like if you're pitching to some VCs, you might not know, like look matters, right? Like it's extremely important. So have a stylist figure that out for you is like a nice thing to have.
Yeah, that's right. There was this joke in the 90s that, in New York, that if you want to hire a really good quant, you go to JFK airport, you find a guy in a really baggy suit and like old-fashioned glasses. He's probably a Russian mathematician or physicist. You just hire them and like they'll be the best quant, right? Like there was a stereotype, right? So because in Russia, mathematicians, physicists didn't really care about clothes. In the 80s and 90s, didn't have a way to care about it.
That sounds like every mathematician I've heard of. Yeah.
Right. So
wildly stereotype.
Yeah. So you clearly can stereotype, right? And another joke comes to mind. Somebody made a joke around Halloween. Like it's ridiculous how adults are dressing up in little suits and and then somebody replied to this, well, every day you put on a dress suit and look like a big guy in a big company. Like how is this different, right? So it's but it was interesting. Obviously there are contexts. Right, so...
and that's one thing that a stylist is extremely good at figuring out as compared to a machine, right? you know, your case was very particular, right? Like, you didn't just go to work, right?
Mm-hmm.
Like, you didn't just go to interview. You went to go interview with a VC, right?
Right.
And so, like, that means that, like, whatever might have flown for an interview attire in San Francisco is now stepped up a notch,
Mm-hmm.
right? And so that's the kind of context that a human can read and try and figure out. Now, how does the human communicate that back to the machine, right? That's an interesting intersection.
Mm-hmm.
How do you do that? How does the machine accept those inputs?
Mm-hmm.
How does the machine talk back to the stylist in some way? And given like new recommendations conditioned on whatever the stylist just told her, right? So there's really, really interesting like cross-feed there.
You don't have, like, you cannot really run deep learning on this because you will not have 3 million people doing VC interviews, right?
Right.
Like, you will have barely a few cases. I mean, you will have an image, right? Like, basically, like, we know how to stereotype, right?
That's right.
But, you know, how do you explain to the machine? Like, you will not feed it a lot of data.
Yeah. I think one of the things that deep learning is really good at is having is supervised classified data sets, right? And it's starting to verge more towards like unsupervised work. Like lda2vec is going to be talking a lot about unsupervised learning.
Mm-hmm.
And we might make inroads there, but for the time being, I think the biggest gains are to be had with how do you optimize like machines talking to humans and humans talking back to machines. And I think that requires a very specific set of algorithms. You need algorithms that don't give you sort of black box results like how deep learning usually does.
Right. Which is unexplainable.
Which don't get me wrong, I'm actually a really big fan, but like usually, you know, there's 2 different kinds of explainable. One is like, do I know what the model is doing? And then 2, given those results, can I actually understand what those results mean? So those things are different. One, I think for deep learning images sort of fails on both of those things. Like you have a bunch of layers in between. You can kind of visualize what those layers are doing. You can kind of visualize them for like individual images and get a good sense. But the output is this, or rather one of those intermediate layers, is this sort of like big giant 4,000 dimensional image vector, and you don't really know what that means.
Right.
You look at one of like, all you really know is it's similar to these other things, and you're like, okay. You can start to figure out stuff from there. On the other hand, sort of on the other spectrum of like models you can do are things like graphical models, things like LDA, which by their construction, which are from the get-go, not trying to be the most powerful algorithm in the world, trying to be the most interpretable algorithm in the world. And the results that it gets you are extremely nice to read off, right? And that's the kind of thing that will let you go back and say, here's my machine learning algorithm, here's what it feeds back to the stylist, right? I can't give back a word-to-vec vector back to my stylist. That's not going to fly. I can kind of try to give her an LDA vector, because at least that's only going to be essentially because it's only going to be 3 or 4 numbers as compared to a word-to-vec vector, which is going to be 100 numbers. And I'll explain a little bit more about this later today. But like that family of algorithms is what you need, what we need to push forward to have better human and machine interactions.
You know, that was interesting. I think kind of the Meetup audience senses this because we have a record number of signups today. You know, we have 300 people, right? We have people from the East Coast who want to see it. So obviously, I think word2vec was a really huge hit with the community, right? But then there are questions. So I think it's like you're really.
Are you sure it's not just the machines getting smarter and overloading the Meetup and just?
I think the recommender
systems.
Actually, you know, this come to think about it. You know, it's interesting because you know the way Meetup works, right? When you start a Meetup group, right? And I started several Meetup groups. You provide. It's very similar. You know, first you give it a free text description what this Meetup is going to be about. And then it matches, it gives you some keywords back, and then you have to select, right? For instance, you know, let's say I can, you know, start as a Spark, so I will say this is about, you know, in-memory computing, you know, this is about kind of type of program with big data and so forth, and then it will suddenly come back and say machine learning, data mining, and then if I select these keywords, I think it does proximity affiliate, and it finds new keywords, and I think for every user, it has a similar system. So I think they have somewhat similar problem. The problem is they don't have a stylist. So you often get misclassified. But I think it's actually, they're pretty good at it, right? So we actually, I think, get pretty kind of cohesive audience. I'm very excited, like they really kind of dig this topic.
Yeah, you know what I'm interested in? I know you said that. It would be interesting, right? What if you did have a human in the loop there for Meetup? It's probably one scale, so that's probably why people haven't done it before. But let's think about it like other domains, right? Like AlphaGo winning last week. what would happen if you gave the AlphaGo recommendations to like that top-notch player, right?
Yes.
To Lee Settle, right?
Uh-huh.
Like, would he perform a whole lot better? How do you actually optimize that? Like, what do you think would happen? Like, I'm really interested in that, right? Like, what if Lee had 10,000 GPU machines at his command, right?
Right.
How big would what if he had the 100th best player playing against Lee Settle and then had AlphaGo on his side?
Interesting.
Like how much machine and how much like human and how well can they work together in like things like games?
Right.
It would be super cool to see, right? I want to know what that would work out like.
Interesting, because maybe it's a different skill, right? Because you can be
You're
a great Go player, but maybe you can be a great commander of Go playing machines, right?
Now, wouldn't that be interesting, right? Like, wouldn't that be super interesting? Like, wouldn't it be great to like kind of like say to your Go algorithm, like I kind of want this like level of strategy, like give me back some percentages that's going to win, like, you know, that's something that the computer is going to be really good at, brute force, like tree searching across a bunch of different things. But maybe the human is really good at like sort of like sensing maybe the long range like strategy or maybe some of the short range ones, right? Like figuring out what the right mixture of like the global thing is. That would be super cool to see, right? That's how I think of like, to bring it back to Stitch Fix, that's kind of what I think of our stylists as doing. Sort of curating the sort of like long-term client experience of like, what are like the individual items, like what's her style, learning about that. And sometimes you don't send items, you don't necessarily send items that they'll immediately like or that you're sure that you'll like. You'll send items that explore and push them in different directions, right? And so you might not like it, you send it back. But you're telling the stylist something with that, and the stylist is learning something about that, right? And so there's an interesting like push and pull here, and it would be really interesting if, just like an AlphaGo player, a stylist could explore lots of paths going forward and see which paths are the most interesting. And sort of this sort of like explore and like and hate the word explore, exploit, but this is sort of like what the field is sort of.
It seems like you need to really cultivate your best stylists, right? And see how they do.
Yeah.
So I mean, obviously I'm very intrigued now. I'm going to sign up for the Stitch Fix beta, which I just learned in this conversation.
Everyone should go.
Honest to God, right? So, but I mean, actually, you just gave me back my hope of the human race, because I was very much saddened, right? I was almost thinking that we're doing something wrong, right? Because we're basically like harnessing gigantic machines to squash little humans in things like Go. Obviously, like we're still much better at many other things, but it's kind of it's kind of gives me hope that, you know, as long as we're in charge, right? Like now it will be obviously machine-aided humans, right? Like and that will come in many contexts.
Yeah, I think there's a lot to be said about this interaction between the two, and I think it's unbelievably interesting.
On that great note, thank you very much, and we're looking forward to your talk.
Awesome, thank you, Alexy.
Thanks.